In this episode of Cube FM, I got a chance to speak to Zain Malik, who's a platform engineer specializing in large scale, multi tenant Kubernetes systems. He shares how his team managed thousands of pods across clusters capped at 950 nodes, and how limitations with Terraform and node pool consistency led them to adopt Cluster API for declarative cluster lifecycle management. Zain explains how they contributed upstream to improve support for AKS, handled critical bugs in production, and integrated GitOps workflows to remove manual intervention in upgrades. In this episode, we take a closer look at using Kubernetes as a control plane, building custom operators for production-specific needs, and maintaining infrastructure reliability with minimal staff. Zain also discusses tooling like kubectl Play, emerging support for partial device allocation via DRA, and the future of efficient GPU utilization in AI workloads. If you're operating Kubernetes beyond the basics, this episode offers insight into what it takes to scale cleanly and build with intent. This episode of Cube FM is sponsored by LearnK8. Since 2017, LearnK8 has been training Kubernetes engineers all over the world. Courses are instructor-led, 60% practical, and 40% theoretical. They are taught in person as well as online, to groups as well as individuals. Students have access to course materials for the rest of their lives so they can keep learning. For more information, check out learnk8.io. Now, let's get into the episode. Welcome to Cube FM. So first of all, what are 3 emerging Kubernetes tools that you are keeping an eye on?
Yeah, I think these days, if I have to mention 3 tools, I would start with Keda. That is like the Kubernetes event-driven, like auto scaling. I think it's pretty underrated, and if it's used rightfully, it has a lot of potential, especially when coming from the custom metrics auto scaling, and definitely it would something that I would recommend a lot to use more in certain use cases. The second is I like the kubectl plugins a lot. Like there's a lot of them that are out there, but particularly one that I think I really enjoy whenever I'm working with the Kubernetes environment is kubectl Blade, that leverages the field manager of Kubernetes to see which loss client has modified the Kubernetes objects, make things really easy. If Kubernetes updated this field, or if kubectl client side apply has updated this field, right? It's kind of like a little inspector without having audit logs, gives you like a really quick preview of what is going on with certain objects, who is modifying it. And it has been like a really great tool when troubleshooting and going through the outages. And the last thing that I have been keeping an eye is the development around DRA, the dynamic resource allocations. Just going like full speed, and it is something that is really promising because it's going to change a little bit how we mount the hardwares or attach the underlying hardwares to our pods. And this is something that I feel like almost while ago it should have been done, the adjustment around it. So this is something I'm looking a lot, especially there are a lot of caps right now moving around. Things like consumable device, or things that will allow us to use partial part of the device and not the full device, like partial GPUs, partial a network card has a capacity for 2 NICs, and we can only use one, mount the another one for another one. So that this is something that I feel like that is the right time for Kubernetes to step up and drive the change with DR. Yeah.
Great. For people that don't know you, can you just share a little bit more about who you are, what you do, and where you work?
Yeah, I'm a software engineer, specializing in infrastructure most of all, and platform engineering. Like my work is focusing on using Kubernetes as a control plane for a while. So I've been building a lot of platforms or operators to say that, or controls, how we know that, to solve any kind of infrastructure problems. It can come from the Kubernetes management, cluster management. It can be even solving some auto railing, other kind of problem that we are seeing it. So basically driving that part from few years now.
Very good. And how did you get into cloud native?
My entry into cloud native was pretty much many years ago, but I think it got catalyzed when I was started working for Mesosphere. And contrary to popular belief, Mesosphere contributed a lot towards Kubernetes and cloud native scenes and open source for that. And I get to be part of that. And that was really inspiring, and especially their work, and influence around the Kubernetes community was really obvious from the start to go. And how they were leading the part in the container orchestration with the Mesa scheduler, and then joining the part in the CSI work they were doing, that was really great. and then later get to be part of the Kudo like initiative that was Kubernetes University Declarative Operator. I get to see like how actually like different SIGs and Kubernetes works and like development cycles, and the community especially, like that was great. So it was really a part like for good chance to be part of a broader community of Kubernetes, and like the like to making it more efficient, and like making it easier to use infrastructure. So I think that's where like probably it started. Yeah.
Okay. And the Kubernetes ecosystem moves very quickly. How do you stay updated? What resources do you use?
Yeah, I think I'm relying on a mix of resources to stay up to date. Like I would not say that like only one source that I just know, like that is the only one that I need to read. I do read the Last Week in Kubernetes Digest, like that is really good for all the Kubernetes development that is going on. I also stay up to date like with a few of the Substacks blogs that are coming around. Uh, Also with your like UFM, like the collection of the article that is coming, that is really great for me to not navigate what is going on, because sometimes new authors come up and uh, really interesting thing is being published that get missed on these traditional channels, right? So I think like that is also very great to have some aggregator like UFM, which I follow to see the what is going on in the community. Yeah.
And if you had to go back in time and share one career tip with your younger self, what would it be?
I would say like focus on the results, like how we say ship it, right? And like that is the most important thing, and then actually like polishing the results and like working on something that needs to be done like in a perfect way. I think that's the easiest path to for the career growth is shipping everything as soon as possible, and later like lean on the feedback, like constructive or any other kind of feedback that comes across that helps to shape the career. That would be easiest part to do that instead of trying to build something that is semi perfect to just to be afraid of like what the feedback is going to be negative or something like that. I think that is like something early in the career we have to, if I could go back, I'd say like just get rid of this part of that, like try to ship it, get the feedback, because we cannot cover all the use cases, and it's better to cover one use case than like trying to cover 10 and actually not shipping anything.
As part of our monthly content discovery, we found an article that you wrote titled Managing Hundreds of Kubernetes Clusters Using Cluster API. So we want to dig into this a little bit more. Your team at City Storage Systems is managing a large-scale Kubernetes operation. Can you describe the scale and nature of your infrastructure setup for our audience?
Yeah, sure. I'm not like working for the city storage system anymore. Like, but last month I changed, but I guess to like go through that because I was part of the whole architecture there. So city storage systems is like they were managing like multi-tenant Kubernetes clusters, and one phase we have like almost like 30,000 pod across different clusters that are running at any time. It can go up and down for sure, depending on the peak times. And the cluster were different sizes that were working. We were working to offer to our tenants. Some were around like 400 nodes, and some would go even like 950 nodes, right? So 950 nodes was just basically coming from the natural limit of 1,000 nodes limit from Kubernetes on AKS that we were having. So we couldn't go beyond that. So we have to divide the cluster at max 950. But in the cluster, the density of the pod were also very different depending on the critical like infrastructure or critical kind of like workload that we were running. It could have like just one or two pods, and on each node that could go like to even to near about 1,000 nodes. That would make it easier to manage. But in a nodes where the density of the pod was a little higher, I think like the limit was already between 300 and 500 nodes. We knew that we cannot go more than that. On those clusters, like at a good day, we could have easily 10,000 pods running on 500 nodes. So a lot of packed nodes all together and running together. Yeah.
What specific challenges did you face with your original cluster management approach that drove you to seek a better solution?
Yeah. So our original setup was, of course, infrastructure as code also, but it was more Terraform based. And there were like several challenges that were like slowing up our speed because we were a very small team and we have to stay up to date on the management of this cluster. But one of the main pain point was the provisioning time. That would take like almost 1.5 weeks to get everything up and ready and offer it to like users. Okay, now this cluster is ready. Now can you use that, right? And the other thing was like the fragmented. number of tools that we were using to manage this cluster. So on one hand, we have Terraform that we use to provision the cluster, but on the other hand, we have a like operator that is managing node pools, right? And then like every time there's like some sort of like synchronization issues that happening between Terraform state and like the other, we will have an issue. And also by the nature of the Terraform was also that if someone goes like a power user or like a sysadmin with a, of course, with a like privilege access and change something in the cloud, we would not know that like till next time we're running Terraform plan for that particular cluster. And when things like these were happening, we had like two issues to solve. First, to fix the state or who did it, like the change. And second was like also like the actual change that we wanted to do at first place. That's why we were running Terraform plan, right? So the work would like become like more like a firefighting effort where you're trying to fix things, also trying to figure out like the impact of what the changes were. And these inconsistencies were like not only like we're delaying like migrations to between different clouds, but also need a lot of like these manual interventions that I was talking about. And that was putting a lot of strain like in a team of small engineers like ours.
You mentioned adopting Cluster API for managing these clusters. For those in our audience who might not be familiar with this more advanced technology, what is Cluster API and what made it particularly appealing for your use case?
Yeah. So Cluster API is a powerful Kubernetes project that allows you to create and manage cluster and using declarative configurations. It's used Kubernetes as a control plane where the cluster definitions are present inside the Kubernetes clusters, different CRDs, and it builds on different abstractions. So depending on the cloud provider, there might be some CRD that are very specific to a cloud provider, but overall, there's going to be cluster object that is exactly the same for all cloud providers, be it EKS, be it like AKS, it's the same cluster object. It represents a Kubernetes cluster. This is the same pattern that, for example, control plane is also like Crossplane is also following to build Kubernetes on top of like Kubernetes itself, using it as a control plane. But what was like more interesting for us for Cluster API was like it's slightly opinionated about how you build those clusters, right? It's not about using the cloud provider API and just get it up and running. There are certain practices, certain like ways to do things that were already embedded in Cluster API that are more easier for us to adopt and like get it more towards production readiness of that product, right? And that abstraction was the main thing when we were thinking about like if we can go multi-cloud, we have to do the migration from one cloud to another one, how we can keep the same abstraction of Kubernetes representation of a cluster across different clouds. And that made us like, that was the main thing that triggered us to go towards Cluster API and invest into that.
Sounds like Cluster API wasn't immediately ready for your specific needs, though. What roadblocks did you encounter and how did you overcome them?
Yeah. So initially, the Cluster API project was designed for self-managed Kubernetes clusters. So let's say like I want to spin up a new cluster in Azure, some virtual machine skill sets on AWS or on GCP. I will just spin up some clusters. All my control plane, Kubernetes API server, etcd, everything's running in those VMs, fully self-managed, and I will just go and start using it with Cluster API. In our case, we was slightly different. We wanted to use managed Kubernetes cluster like AKS, right? So it was not a self-managed Kubernetes on top of Azure, but AKS. That was still experimental, the support there. And there were like small, like initial like support that was already in place, but few things that were missing in that sense. Like, for example, when you're creating a Kubernetes cluster or like in any other sense of for AKS, if you're running upgrades, we wanted the control plane version to be different than node pools. Because on the large scale deployments, we cannot just go and upgrade Kubernetes. Like all the control plane get upgraded, the API server and node pool at the same time. This is not how actually it works. We will just upgrade the API server, make sure there's no inconsistency, no clients are using like are broken. And slowly over the period of weeks, we will pick up node pools to drain, to upgrade that and do that, right? So that was not there in Cluster API. So like a few other things that were needed, for example, number of max pods or other things that we need to change that was not supported. How did we solve that? That's we just went and dropped into the SIG of the Cluster API for provider Azure, and I think like the they have a really awesome community of maintainers who are maintaining that project, and explain to them like this is what I want to do, and this is like the problem that I see, and how they see that this would fit in a production readiness roadmap for that. And they would just guided me like how to do those contributions, like tell me like how to open those like PRs, how to test it out. And most of those like features that I said were missing were done by them, but others PRs I open it. So basically the spirit of the like the maintainers that is like, okay, let's keep it, let's valid use case, we're going to help you get there. And actually like in a period of like I would say 1 month or less, like the main critical feature that I would say like, okay, without these I would not run cluster API in our like infrastructure, we're almost done. Like so that's how like it went. Yeah.
Even after creating clusters with Cluster API, there seems to be a big gap between having a basic cluster and having one that's truly ready for production workloads. How did you address that?
Yeah. So Cluster API does offer like a very robust fundamental like foundations to create like a production ready cluster. But like there are also like some part of things that are very specific to business needs for each organization, right? So there are like certain things where like as I said, like Cluster API is slightly opinionated about how to do things, and that would not fit inside the Cluster API. One good example is like we want to have access to normally to one container registry in Azure AKS cluster, but sometimes we needed like multiple container registry to have access to. We wanted to very granular access to those, right? And that would not fit into the cluster API like scheme of a cluster definition, where like we are defining which node pool is going to have which one. But that was the best part of choosing cluster API because it's a Kubernetes based control plane. We could just write another operator that is like creating that resource alongside the cluster definition CR, and that would have like the additional configuration that we need. In that sense, we could create the ACR permissions, like to pull images to our cluster, to multiple of those, and kind of like work around that, and without imposing our needs, particular needs, on the community, where we are saying like this is very particular niche kind of need. You should use your API, like you should support that use case. Otherwise, it's not helpful for us, right? So that's like I think that the main lesson for us was like we can leverage everywhere the community is taking us with cluster API, but then we can take on from there to get it like more, I would say, production ready and robust for our needs.
Node pool management seems to be a particular pain point in Kubernetes operations. For those who might be exploring advanced cluster management, what specific challenges did you face with node pools and how did your team solve them?
Yeah. So node pool management is particularly like very interesting, I would say, and challenging in many aspects. And depending on like which part of the project you're working or which kind of like problem you're solving, you might face one set of problem or others. And actually, node pool concept itself in Kubernetes doesn't exist. Like there's no node pool Kubernetes object itself, right? So what we do is like cloud providers underlying like APIs like virtual machine skill sets will be seen as a node pool inside AKS cluster, or JKE instance groups will be seen as a node pool inside like those ones. So once we are relying on an underlying API, it's very natural that we bring the limitation of that API inside like Kubernetes also, right? So if I'm creating a virtual machine skill set in Azure, it has certain limitation. It should have the same hardware, right? Spec. It has also like the number of like the configuration, like we are setting it up is also immutable. We cannot change it once we have created that. So if we want to recreate a node pool or like change certain configuration, like for that, at some point we cannot do that because we are limited by the underlying API of the cloud provider, and it might come across as it's a node pool limitation, right? But it is just the node pool abstraction that we created on top of cloud provider's API is what is actually limiting it, right? And to do that, like I think like how we were doing is like automation strategy of our like node pool operators. We can just like build an actual abstraction of node pool that is very true to our needs. So for example, if we are changing some sort of like immutable things that will properly drain the old node pools, create the other one, and these kind of things. So these challenges I think like are still present. And when you create like a cloud provider node pool, there's certain things that cannot be changed. So and it's very hard to be right at first. Like I think almost impossible for any team. Yeah.
Throughout the article, you mentioned your commitment to GitOps principles. How central is GitOps, or sorry, how central was GitOps to your automation strategy? And how does it fit with the Kubernetes operator pattern you've implemented?
Yeah. So I think GitOps is like very fundamental, not just for the cluster management across like even the development of our own operators control. Like we're still using GitOps also like to deploy certain like operators in itself. For us, like the main like the source, even before like moving from Terraform to let's say to cluster API, it was still based on GitOps, right? So we need a single source of truth. They're saying this is the source of the truth where we can do that. We can review through PR processes, like land it, and it will automatically get deployed to the target cluster or wherever management cluster we are running over, like the systems of the cluster API or Terraform setup, right? And for example, this is very important for us when we are doing like very critical kind of operations, let's say node pool upgrades. So to do that, it cannot be dependent on like someone's laptop or someone's is doing it through UI without any review process. They will open a PR and say like, okay, we want to change from Kubernetes version like 128 to 129, and we can all review the process to say, okay, this is what the impact is going to have. We should not do the all node pools upgrade at the same time, one node pool at a time. So this is the sort of the thing that was very fundamental for us as a source of truth that GitOps is providing us. But at the end of the day, like there are also like other parts of things like that. If they can provide us the same kind of things, it's still working well for us, right?
Being an early adopter of new technologies often comes with its fair share of risks. Can you share an example of a challenge or incident you faced as an early adopter of Cluster API for AKS?
Yeah, definitely. I think I can share something like a war story here for the Cluster API. It was very interesting because this is like just a good example. Like no matter how well you have tested it in your E2E, and no matter how well you are trying to do it in your like POC clusters, staging clusters, things break in a way that like you least expect, and that is always the bet with the emerging technology. So there's a lot of benefits coming from it. So in our case, like there was a bug in Cluster API, especially with the AKS like CAPC implementation, that would be only be triggered when we are scaling down the cluster, right? So in scale up, it's not happening. So when we were migrating from Google to Azure, we were only starting with one node, two nodes. Like let's now jump to the 5%. We were always scaling up. We were never like going downwards. Went towards to 50% gradually. There did the jump to 80%, and then we're like, okay, this is all looking so well. Nothing is going wrong, and we shifted the full cloud switch where we are 100% is on Azure. And a day after the peak, when the first scale down event happened ever, this cluster, which was the kind of like the thing that we missed with multiple node pools, there was a bug with the provider like ID of the node pool that or nodes that we were setting through CAPC of the cluster API that could be mixed between different node pools. That means like it would not identify correctly the node that it's supposed to delete, and that could trigger a cascade effect of it will mismatch between different node pools and delete everything from one node pool, right? So we had a scale down event that happening like in multiple node pools, and about 60% of our nodes were like totally deleted, like without any graceful like code on drain. They were just gone like fully, and then that definitely caused like a outage. We of course everyone was paged, and we were trying to figure out like who is actually deleting the nodes. Were able to figure out the cluster API itself. We just totally like scale down the cluster API deployment, scale it up like the notebooks manually ourselves so we can mitigate it. But the good part of that was like once like we told this to a like cluster API maintainer, and this was happening in the evening of Europe and their morning, they offered to jump in a call like right away. Like, and they were like jump in a call. And I think like we were in a call for 15 minutes, and they were able to identify, okay, yeah, this is a bug that like is with provider IDs, right? And 10 minutes later there was a PR, like, and 30 minutes later we had a like a fixed which we could test in our staging cluster, obviously, and like we can try it out if this bug is fixed or not, right? And so there was like very like I would say like SEP 0, SEP 1 kind of incident that happened with us, but doesn't mean like it was not like that we should like avoid this cluster API. That is something that has been long fixed, and this is something that, of course, it's a issue that like if you are first early adopters, you will run into it. And I think like as because we run into it, like I'm pretty sure like many other customers or users who are using Cluster API, they are not running into outages because of that.
Your team managed to double the number of clusters while maintaining the same number of engineers. How did this transformation impact operational efficiency and team dynamics?
Yeah. I think the evolution of like our tooling and process automation meant that we were doing less firefighting, less spending time on the node pool upgrades, and without growing our team, we were able to manage a bigger number of the clusters, Kubernetes cluster within the team. And that was like the operational efficiency that was increased dramatically, like over the time in a short period of time. And the number of the engineers that were dedicated for the node pool upgrades was also reduced to just one engineer doing alone the task of upgrading all the production clusters, right? That meant that that we were using less amount of people on doing these things, and were able to even rotate different engineers. Because before Cluster API, it was like just one person who had the total ability or knowledge of like 360 of how the node pool upgrade is gonna play out, and that person was like dedicated person to do the upgrades. But like with Cluster API, we would know that like we just have to do the GitOps, like PR, approve it, and just make sure that things are going as we were expecting that. And before also, like when we were doing upgrades, like always some outages were happening related to the users, right? So like some workload that is stuck, that is not letting us drain, and like you will get like impatient with that. You'll say, okay, maybe I will just try to delete that workload. User will come and complain why this was deleted at first place. So these kind of things where we were allowing our engineers to do that. But after this whole automated operations, we just set up like a defined rules where we are not gonna disrupt a workload if they're following certain practices. There are certain time windows where we could disrupt it. So removing the human in the loop of this kind of operations was really helpful for us to actually double like the efficiency in the sense of managing Kubernetes operators, the Kubernetes cluster, and also managing like the upgrade process that we were doing.
Looking ahead, what's next on your roadmap for scaling Kubernetes management even further?
Yeah, I think like right now, what is the topic that is gaining more and more is the multi-cluster management that is coming across. So this is something that we do manage multiple cluster, but like not like from the same like operator, right? Multi-cluster operators where workload is deployed across multiple clusters and like scaled around like different clusters where things are evicted from one cluster and deployed to another cluster. I think there are like a lot of interesting tooling that is coming out, like the Fleet Manager from AKS or like Orchestra that Google just announced also. Karmada is also there. I think like that these things are coming out to their maturity to a certain point after a few years being experimental. So that is something that I'm also keeping an eye on that. But other thing that is also that I'm constantly working is the Kubernetes clusters efficiency. So it has been long that we are complaining about like when you run things on Kubernetes, there's a lot of waste, and that waste is like now I think like it's coming like to catch us up. So trying to keep up with those things is gonna be like the priority, not only with CPU optimization but the GPU optimization. How to do it like in a open source way, in a standardized way, without causing any kind of reliability issues.
For teams who might be inspired to follow a similar path, what would be your most important advice based on your experience with Cluster API in automating Kubernetes management?
Yeah, I would say like my advice would be like to take the bold bets on the emerging technologies, because there's always gonna be some issues like with any piece of software that is open source. Just because others are not using it doesn't mean like we should not use that. Because if we start from scratch, there's a lot of work that we're gonna put into that. And if we bet on that and like just contribute to those like deficiencies and like help that mature that part of the ecosystem of Kubernetes, that is going to benefit them in the long term also, like to the teams, because this will result in a more mature product which require not only users but contributors also to make sure that this is evolving to a better place. And the second is like also like do not be afraid of like engaging with the community. Go to the SIGs like meetings and then be involved less of like like hating, more of like like appreciating them, in the sense like if someone is not solving something, it's because they have a lot on their plate already. And that's an opportunity, not like a thing that to say like, okay, this project is moving very slowly. I think like that's a, for me, I would see it as an opportunity where you can go and contribute to that. And I think the last advice is like to leverage the operator pattern as much as possible, because this is something that Kubernetes is giving us for free, like writing operators, writing controllers, and writing all sort of like frameworks that build on top of Kubernetes patterns are gonna like avoid a lot of it's gonna eliminate a lot of human errors. Like it's gonna streamline the processes. It's gonna help them to put the like the baseline of everything when the platform they're building, where everything is living within Kubernetes as a Kubernetes objects.
What's next for you?
So I'm trying to, as I said, move toward like the efficiency part, like Kubernetes efficiency. This is something that I'm trying to figure out. I think this is like how the market is moving towards is also very, very interesting. And the lot of waste that is happening on CPU and GPU, I think that is something that there's a lot of opportunity there to be fixed. And we should also like leverage that part, how to make the streamline the process around that. I think the good example is like in China, like where they have a deficiency of the GPU chips, like how they are able to work with less, like optimize like every single like memory byte that is running on GPUs to train their models, to train their frameworks. A lot of cool operators that are coming out of from their China also, which is like also actually putting them in front of us, right? In that sense of getting the most out of less. So I think like that mentality has to come around, and instead of like thinking about like we need like like 1,000 GPU clusters or like more and more chips, I think there's a lot of work needs to be done still, like to use it efficiently, to keep these things and like bring all the things that we have learned from the Kubernetes pattern, like from the node problem detector, like Orkeda or other patterns that we have been proven to be work at scale. I think that the whole AI community and ML community needs to be leveraged from that also. So I'm looking towards that and working on the different projects that are like tapping into that space of GPU optimization. And yeah, this is looking really cool so far.
Plenty of work to do. What's the best way for people to get in touch with you?
You can reach out to me in LinkedIn, like just search my name, Zain Malik, and I'm pretty sure like I will appear there. I work with Access currently, so that would be the right way. Or GitHub is also there, so just shoot me a message also, like, or anything that I'm working. It's my handle is also there, and yeah, I think that is like the ways to use out, not really engaging on X anymore that much. So like LinkedIn would be, I would say, the best way these days.
Well, Zain, thank you very much for your time today. Thanks for sharing your knowledge, and looking forward to catching up with you in the future. Take care.